Okay, kiddo, I'm going to make this as quick and short and sweet as I can. In order to understand these angles um, and this quiz that you're taking, you have to understand a few definitions first. So I'm going to start there, okay? Once you commit these definitions to memory, this whole process gets a lot easier. And most of the terminology that you're going to use throughout the rest of geometry, you actually learn most, if not all of it, here in this exact lesson that I'm about to give you. So it doesn't get much harder. These are the basic vocab words that you need to know. Vertical angles, first of all, are something that's called congruent. And you're going to hear that term a lot. If something is congruent, think of it as an identical twin. It has the exact same size and shape as something else. So identical twins, one would be congruent to the other. You don't use that term for people very often, but you get the idea. So if it's not the exact same size and shape, and in this case, when we're talking about angles, you can tell if they're the same size and shape if they have the same measurement. So if it's a 90-degree angle and another 90-degree angle, well, those two angles are going to be congruent to each other because they're going to have the same size and shape, or when you're talking about lines, angle measurements. Okay? They're also going to be a mirror image of each other. So it's got to pass both of these tests. You're going to have to go, are they congruent and are they a mirror image from each other? So let me kind of show you what I mean by the mirror image. That's better understood by looking at it. Here I have two lines and they've crossed each other, okay? I have this angle that was formed right here. It takes up this space. It's technically right here. That's the angle, but it takes up this whole area. Well, if I were to flip this on its head, flip it upside down, it's going to give me this exact angle right here. Okay, this one that occupies this space. So as you can see, they have the same angle measurement. They're both probably roughly 70-degree angles, something like that. And they're a mirror image of one another. So if I had placed like an imaginary mirror right here in the middle of them, they're a mirror image of each other. Okay, so it passes both of the tests. So I would be able to look at this angle right here and this angle right here, and I would be able to see that they were indeed vertical angles. I can also do the same thing, let's see here, with this angle too. This angle is a vertical angle to this angle. So I hope that's visually clear to you. They both pass the congruent test, they both have the same size and shape, and they're mirror images of each other. Since they pass both of those tests, those two angles are called vertical angles. It's not going to even matter if I add a third line, because then I still have the same criteria. This angle will be a vertical angle to this angle. This angle will be vertical to this angle. This angle is going to be vertical to this angle. So I don't want to beat that like a dead horse. That's how to identify vertical angles, by looking at them. Okay? Some more definitions. Supplementary. You need to know that if I'm referring to two angles and I'm talking about them like they're supplementary, I say, hey, look at those two angles, those are supplementary. Well, what that means is if you were to figure out what they equaled, like one was a 95-degree angle and one was an 85-degree angle, I add those two together. If they equal 180 degrees, then they're supplementary angles. Together, they equal 180 degrees. Complementary, very similar. It's just instead of adding up to 180 degrees, a complementary set of angles is going to equal 90 degrees together. So commit that to memory. And you can pause this video at any time, since I know I'm covering it kind of fast. But you need to know those two terms, because if they tell you two angles are supplementary, then you can figure up a lot of stuff. So here I have a line and another line that came right to it, formed this little point. And I'm going to call this angle A. I'm going to call this angle B. Okay? If I know that angle A equals 60 degrees, and I know that angle A and B together are going to be supplementary, then I know that they're going to equal 180 degrees together. And if I already know that this one is 60, then I just need to know what the remaining is, because it's going to be 180 minus the one I have already, that's 60. That's going to give me 120 degrees. Because I was told that A was 60, I know that they're supplementary, then I know that this one has to be 120 degrees. just because it has to equal 180. Why does it have to equal 180? Because I told you it was supplementary, and that's what that means. Here I have a 90-degree right triangle. It is a 90-degree angle because it's got that little box. If you ever see that box, that triangle is a 90-degree angle. And I also threw in this dumb little line right here, and I split it. So now I have this angle, and I have this angle. I know that the both of them together, because of that little box, is going to equal 90 degrees. So right off the bat, I know that they are complementary because they equal 90 degrees together. But what if I was just given this, and this I knew was 40 degrees? Well, because I know that together they have to equal 90, I'm going to subtract the one I have, and I know that the other one then has to be 50 because I know they're complementary, and I know this one equals 40. As a result, since they're complementary, this one and this one have to add up to 90, so that one has to be 50. 3 more definitions. An obtuse angle measures more than 90 degrees. So if it's obtuse, it's going to be bigger than 90 degrees. It's going to be open and wide. A right angle, we just talked about, it's going to measure 90 degrees exactly. And an acute angle is going to measure less than 90 degrees because it's cute. Oh, look at this little cute. Okay, that's dumb, but that's how I remember it. So just make fun of me if you will. Let's see what they kind of look like. An obtuse angle, like I said, look at how it opens really wide. Okay, it's leaning backwards. Right angle, always look for that little symbol right there, the little square. And an acute angle is obviously going to be this right angle closed up a little bit. Okay, so it's this right angle, and it closed itself just a little bit. So it's smaller than 90 degrees. That means that it is an acute angle. So how do we find the measurement of an angle? Easy, just like I said. Let's say this is a 60-degree angle. This other one, because I know since they form a straight line together, anytime they form a straight line, that's going to be your indication that it's 180 degrees. If it's 180 degrees, it's going to be supplementary. Because I know that together they got to equal 180, I'm going to take the 180, subtract the one I have, and I've got 120 left, so I know that has to be 120 degrees. That's how it basically works. Now let me show you practically in your quiz how that's going to work. This says, which pair of angles in the figure below are vertical angles? We know what vertical angles are. They're congruent and they're mirror images of each other. So let's put these to the test. Angle AKC. So you would go angle AKC. So we're talking about this whole area here. Is that vertical angle to TKI? TKI. So we've got this whole thing. You kind of have to just ignore this PKR line in your mind. So we've got this whole area here, this whole area here. We've got these two angles. They share the same middle point, which is called the vertex. You might write that down if you don't know it. The middle point is a vertex. And vertical angles also have to share the same vertex. Okay? If they didn't, they wouldn't be mirror images of each other. And these are. So they're congruent, they're mirror images of each other, and they share a vertex. So that's going to work. What about IKR and AKP? Well, that's this one and this one. They share a vertex, they're mirror images, and they're congruent. Yes. AKT and PKC. AKT and PKC. Well, I've got this big one here and this littler one here. They're not mirror images. They're not congruent. How about AKP and PKI? Well, these are sharing a line together. Anytime they're going to share the same side, that ain't going to work. Plus, just by looking at it, you can tell they're not mirror images, and they're certainly not congruent. So that's not going to work either. In this one, it's just set up a little different. It's not nice and even. You got kind of a missing line. Your brain probably wants to kind of put a line there, and it's not there. So let's look at these, AYS and LYS. So I've got AYS and LYS. Well, no, I've got this angle and then this big angle here. They do form a straight line, so I know that they're supplementary because together they're going to equal 180 degrees, but that's not what I'm looking for. They're not mirror images of each other, and they're not congruent. So that's not going to work for a vertical angle. How about AYE and HYL? Well, these are a little bit closer to being across from one another, but they're not mirror images, and this one's small and this one's big, so that's not going to work either. How about EYL and AYS. Now we're getting somewhere. Mirror images, congruent, share a vertex, yes. SYL and EYA. These, you're just going to look at these two. You got this angle, and directly across from it, this angle. They're congruent. They share a vertex. They are going to work. And they're mirror images of each other is what I meant to say. Here I have, even though this has right angles, doesn't matter. It's still the same basic principle. I've got RDY and NDA. They're straight across from each other. They share a vertex, and they're mirror images of each other. So they are at the very least vertical angles. They're not a linear pair because it's not a pair of points on a line, and that's what a linear pair is. They're not complementary because this is a 90-degree angle and this is a 90-degree angle. So if you added them together, they'd equal 180. And that is a definition for supplementary. Vertical angles, they must have the same vertex and they must be congruent. They can be small, meaning they're not obtuse, and they never will share a side. Okay, the measure of RVE. This one looks complicated, but it's not as hard as you might think. So we're looking for this angle, RVE. And what we know about vertical angles is, man, if I only knew this angle, since it's going to be congruent to this angle, since they're vertical angles, if I knew how much this one here measured, this AVL, then I could know how much RVE was because they're going to be the same. But they didn't give me either one of those, so what do I do? Well, here's one thing I do know. This line, this angle, all of these angles together form a straight line. That means that it's going to be 180 degrees altogether. It's going to be 180 degrees. So these three angles together, nobody said it just had to be two. These three angles added together equals this straight line, which is 180 degrees. So what I do is I take 180 degrees and I subtract the two that I have. So 180 degrees, and then I'm going to subtract 135, and that's going to leave me 45 degrees for this, because all three together have to equal 180 because they form a straight line. So that means AVL is going to be 45 degrees. And since this is a vertical angle to RVE, which is what they're asking about, and those have to be congruent, I've got 45 here, so I'm going to have 45 here as well. Now, Now this one is just a little bit different, but it still applies the same principles. We know that angle ANR and angle ENV, these are vertical angles, which means they equal each other. But they didn't tell us how many degrees. They gave us this little mini equation. But don't let that throw you, because all we're going to do is we're going to set it up. I know that this angle equals this angle equals this angle, and these are the measurements I was given, so I'm going to set up an equation. My equation is that angle, which is represented here, is congruent as a vertical angle to the other one, so I can put an equal sign between them, and it should still work. I'm going to do what I have to do here. I'm going to subtract 12 from both sides. That'll leave me with 8x equals 5x plus 45. Then I'm going to subtract 5x from both sides. That gives me 3x equals 45. Divide by 3 to get x by itself. X is going to equal 15. Now going back to my original equation, they're asking about this angle. What does it measure? They don't want an equation, they want a number. So since I know what x equals now, I can go ahead and finish this problem. It's 5x plus 57. So everywhere I see that, I'm going to put in a 15. So what I'm going to have then is 15 times 5, which is going to give me 75. And then I'm going to add that to my 57, and that's going to give me 132. So then I know this has got to equal 132.